Bismillah ar-Rahman ar-Rahim. Now we want to run our model. How to calculate these parameters, which is we need to develop the damage curve and risk curves. Now we're starting. We at the first. We open our HEC RAS model. This is the simple HEC RAS model. You can download from US Army Corps of Engineer Hydrologic Engineering Center. We have already, because we are at the first, we discussed that because it's time consuming, therefore we leave, and we have already have videos on our in our YouTube channels and in our pages. You can visit our YouTubes. You can download it, the videos. There is many videos, but also the modeling. We open our model. We have already viewed that. There is across this. At the first, we should know about all that I will not in detail, but like a summary. I want to introduce all the steps. At the first, we should open the RAS mapper. This is the RAS mapper. It's work as GIS, or it's used for geometric model, to build the geometric model. We have already calculated the all parameters, like depth of water for each return period. Have to see the return periods. From this part, wave edit steady flow data can open our for each region for 2 years, 10 years, 25, 50 and 100. 4 number of profiles. We have used for 2 years. We opened our frequency analysis. Presentation. This is Kabul River at Parmon, Kabul River, sorry, at Police Ukhta. This is the historical data we have obtained it from Ministry of Energy and Water from year 1964 to 1982. This is the drainage area, and this is the frequency analysis. From this, we have obtained it for 100 years return period 152 cubic meter per second, and also for 50, 90.1 cubic meter per second. For 25 years return period, 54 cubic meter per second. For 10 years return periods, 25.8 cubic meter per second. For 2 years, it's normal. For 2 years, it's 5.17 cubic meter per second. This is plotted in this graph, and we use this, and therefore for each profile for 2 years 0.517, for 10 years 25.8, and also for 25, 50 and 100%. Then the reach boundary condition at outlet or downstream and upstream. We use the normal slopes. How to calculate the normal slopes I will show, and I have already discussed this in our video. You can visit our YouTube channel and also subscribe for our new videos to know about that, inshallah. This is the upstream. This is we have used the normal lift. The normal lift depends on the slope and downstream. How to calculate this slope? It's very easy. We come to RAS mapper, open the RAS mapper, For example, this is our reach. Like I want to measure the slope. Come to geometry, to river, edit, or sorry, not come to measurement. Come to here. I want to measure in this area, in this location. I want to measure the slope. Like to this, double click or enter. Length, and this is the slope. But the slope should be entered in positive, not negative. Yeah, because it's to the this is the method of calculation of slope. Now this is the result of our simulation or our model. We can update them to our elevation model. Come, right click layer properties, come to update per screen. If we come here, this show the depth of water, 2.2 meters, like there 0.8 meters, and here 0.2 meters, and this area 0.2. If come to here 0.4. For each our location, if you want to measure the inundation, it shows. But in details, we use the ArcGIS. This is the HEC RAS model. Then to export and import the HEC RAS model, for import the file from HEC RAS, we use the HEC GeoRAS. We will share this extension with you, the setups, and also you can download it. It's free. If we come to each for each return period of the water profile, we simulate them. This is for tiers. You can see it. I will slow the speed. You can see. For 200 years return period, and then we come to velocity. This is the velocity. This is for tiers velocity, and we can update them. For tiers, and each point or each location we can measure the velocity. There is 0.7. There is 0.4. From this is the indications. And if we run this, and this area, the velocity is very low, 0.3, 0.3, 0.2. But in the main channel it's very high, 1.7, because it's short. Its section is very short, and in this area also 2, and this area 2 also. And each point we can measure the velocity. Then for the purpose or to achieve our goal, we should export this and import by HEC GeoRAS. We close them, and then we come to the file. Open the file menu, then come to export GIS data, where we want to water surface extent, and then select the profiles. Like there is, if there is clear, there is not selected. If we want to only work for 100 years, we should select only the 100. If we want to import or display all or calculate all the return periods, then select all, and OK. Then we need the velocity or shear stress or string power. No need for the only we for the flood risk analysis. We only need for velocity and flood inundation or depth. Therefore, only we select the velocity and water surface and water surface extent. Then we should define the folders, desktop, come to our project inputs, come to GIS, HEC RAS reprocessing, and here we should store exporting by the name of project and save, export. Okay, it's now exported, and we also can see the water profiles for each return periods. There is the EG energy grid line, WS water surface, and sometimes it's critical depth. We also can from whereabouts critical depths. This is the critical depths in red colors for we can show the river stationing also, and we can from Lebanon ensemble to ground. Ground. Okay, too smooth. This is the water profile, water surface profile, and also we can see the cross section. We also need to ground. This is the cross section. Each cross section. Why like this? Because this is the LiDAR. This is the building. This is the street. You know. The LiDAR measure each the height of the buildings like topographic survey, but topographic survey cannot survey the height of buildings, but the LiDAR can do it. Come to other cross sections for each cross section. This is the buildings. This is the streets between buildings. You know. Maybe you are understood, inshallah. And come to that 3D perspective. You can see in 3D perspective, come to grade. This is the 3D perspective of the river or stream. And this is the for each water surface profile. Now we close the HEC RAS because we have already prepared this model, and the video of preparation is you can reach there or visit our YouTube channel by the name of Hydrologic Engineering Counselor. We close them, yes. Then we come to open our ArcMap. This is the ArcMap window. It's opened. Now this is the extension of HEC RAS. For the first, we should save this where desktop in our project inputs file and model run. Then come to RAS mapping, because we do all the calculation or the necessary steps in HEC RAS. Then we want to import them. We use the menu of RAS mapping tools. Come to layer setup for the first. What's the name of your analysis? Give or enter the name, project, then come to, first of all we should convert our file, convert for conversation, then come to desktop for the project inputs for our model, this, select and open, and then okay, this is converted from SDF to XML format. Then come to our layer setup, we enter the name, come to our RAS.js export file, desktop, project inputs file, this, open, then come to our triangular irregular network, open them, from where, from our training project input files, where is project input files, this one, there is the training, the tree iron model, select them, open, then come to where it should be stored, then select our output or location, and model run, and then rasterization cell size, in which raster or cell size use for flat extent 1 meter. It means that very flexible. Then okay, now we import our TIN and our project. This is the TIN model of our project. It's very heavy. What? 1 meter, yeah, 1 meter resolution. It's like the data. It's built from this. You can see this is the river of Kabul River, at Corte C and Corte Chore. It's very dangerous area because there is now the river is very narrow, by built up area, and by the encroach of structures and buildings near to the channel or river. It's very dangerous. This we antique mark for speed up of our model. Then come to import RAS data. Import RAS data. Then okay. Only okay because it's already defined. Successfully imported the GIS codes. Now the band points, velocities, water surface extent, river to diorite stream alignment, cross sections, bounding polygons, mosques. This is the mosques for the whole area. We have to study it, and the holder and the terrain model. Then come to for the other steps, inundation mapping. This is very important. Our all focus on this. We then come to the water surface generation. For the because our time is so short, we only select the one. This is the method. You can select them one by one. We use the 100 years return period flat extent. Then okay, the water, it's imported. Then come to inundation mapping option, then come to floodplain delineation using raster. We select our 10 years return period water surface profile, then OK. It will be import the inundation or water depths for each area of flood extent or flood prone area. You can never find this video, inshallah. I will give you the guarantee, and YouTube's other search engines like Google or other. This is imported successfully. This is the water surface. This is the depth of water or inundation. I untick mark the TIN model of water surface, and then untick mark the mosque holders, bounding polygons, X cross-section reaches, water surface extents, velocities, and banks. And this is the depth for each. I want to show it very clearly. I import the raster model. And then we convert this to head sheet to better view. No, this is I am zooming. I will full extent it. What can you see? I will come to surface to head sheet. To better understand and to better view, we should generate the head sheet model of the terrain model. That's very nice. And the result. Okay. This is the head sheet. Here for better interpolation. This is the full extent, and this the whole area of our study. If I want to zoom in this area because it's very, you can see for the better. Then we
there is full screen, but here is not.
Yeah, maybe I don't know why. Yeah, this is depending on the resolution of the screen is not very good because they cannot support this. Therefore, it's yes. I'm sorry, but it's in video records. It's include of those video records, and you can see this better. But on screen, it's the problem here. But this area is important for us. Then we come to import our velocities. Then come to velocity mapping. Select for 100 years return period. Import the velocity. Okay. This is the velocity. Then I want to okay, this is also imported successfully. then I want to do the other steps for calculations. From all this, what's the meaning? Then come to the algebra or maths to convert the flat inundation to, this is the raster. This cannot be stored. It's the raster file, and we cannot. It's not geometry file. We want to convert to geometry file. Therefore, we need to math or algebra. We come to the special analyst. Come to math. Select them. For the first, I have select. I have noted that. For the first, I want to first of all I want to produce the flood intensity. How to calculate it? It's very easy. The remote sensing technology, or especially the ArcGIS, is very good for producing the risk analysis and risk assessment maps. Then come to search, or then come to raster calculator. Come to raster calculator, special analyst. Then velocity by water inundation near depth or depths. Then where we should store project flood intensity FI. Save and calculate. For each area, this is the risk analysis. This is the step for risk analysis. Then we from symbology we classified it for each depth, like for 3 for each. Then come to classify, yes, and 3 class or 4 or any class. I want to in 3 class: low, medium, or high. Thank you. And then change the color for the velocities. You can vary. That means from 0 to 1.4 the water velocity, and we in this area, in this color. And yellow color, it's from 1.4 or double 4 to 4.2 square meter per second. This is the medium risk area. This is a low risk area. This color, the green color, and the red color is the medium risk, and the red color is high risk. Its velocity is so high, from where? From 4.2 to 13 square meter per second. Inshallah, maybe you know about this is the risk analysis steps. Come for the each. Then we have to know about. It's very difficult to each the roads we measure manually. For this we can do the automatic. First of all, we should import the shapefile of roads. Come to shapefile of roads, and then import it. This is the shapefile. I will change the color to red. This is the roads. You can see. This is the road network for whole the area. But this is very difficult. How to know for each flood intensity or for each depth of water? How we know which road will be affected? It's very necessary. Then for this, we at the first we should convert our raster of FI and our inundation to geometric file. For this purpose, we go to these steps. From math, for the first less than 1, math, come to math, less than, logical, less than, where, less than. select our inundation or dipped or raster file or grid file, then enter the one. Smaller or less than one. Okay. Then select OK. Inshallah, maybe you understood. Yes. Now V. This is no color. Come to this. The green color. That's the green colors. What's the mean? The water depth is smaller or less than 1 meters. And which areas? In this areas. And this green areas. Oh, for how to know which road affected by this depth, then we come to intersect. From search, come to enter intersect, come to intersect analysis. Yes, there road shape file and water depth. Where is the water depth? Less than or less than? Less than. Bank point, water services. Why not? And then we select this. Roadshoot file. I'll cancel this. Come to less than. I want to calculate then again. Less than from water depth from 1. Where should training project model run. To check this. Okay. A road and I want to close them. This is the common sometimes it's occur this errors. Yeah. No. Yeah, it's now. Yeah, it's intersected. It's already I have, but it's in progress. it's huge file. This is the length, but I want to remove this accurately. Do this again.
Sometimes take time.
Yes, but no, I want to close them. File, save, and close, then open again. Run model. This is the problem of cracked softwares. Sometimes cannot run properly and cannot calculate the data you want. And then come to intersect. Canton. System, special analyst, math, logical. I want to check. The intersect options not work properly. I don't know why. Before I showed you, this is very good work, but now it's cannot be. I don't know why. Now it's work. It's can. This is the machine problem. It's the software problem. Then list them. This one and select the one. No, it's already calculated for intersect analysis. It's not. Come, roads, velocity. Oh, sorry, I'm so sorry. I'm confused because it should be converted to the geometry and then import. Or also not. Remember me. At the first I saw that the first we should convert the grid to the geometric files. Raster to polygon. We use this and come raster to polygon. Then we select this indentation, this, like or this, or remove this one. Select the list them. List them. Yes. Then OK. Yes. Now it's converted to raster file. We can check up in the attribute. Now this. Yeah, this is the geometry. I'm so sorry. I missed them at the first. I don't know why. I'll also note them. less than if it use the intersect to deep, and also in the note also it's not. Then come to intersect option. Intersect. To intersect analyze, select root and less than 1 meters inundation, select them and intersect all the fields. Okay. Then it will be cut the roads which is affected by less than 1 meter water depths. How to? I will untick mark the all. This. I will change the color to this. This is the roads which is affected by the water depth less than 1 meters. You know how to know about the lengths of each of them in meters. Then come to the open attributables, come to the lengths. This of each
area is also available.
Area area is available for the less than for the option of raster less than 1 meter. Open the attribute. This is sorry no, this one. Open the attribute. This is the area. This the 0 is null area. No, 0 is null for this. This is the total in meter, square meter. It's maybe from this how to calculate. Then come to the Excel. It's for only for one for the 100 years return period. We do this process for each return period. These steps. The same procedure, yes. Procedure is the same, but the inundation depth is different. But if we calculate this for greater than, I will give you another example, like for polygon greater than equal.
It's convert in not.
No. Oh, sorry. For the first, I want to convert. No. To the math, I want to calculate the listening depth. No. Then I want to convert the raster form of 100 years depth, water depth. Then come to 2 meters. Sorry, it's less than 1. It's 2 greater or is equal to 2 meters. And come okay. Select the. What's the mean? The 0 is null. Okay. This color. I want to change this the color to yellow. That means the red color, the yellow color is the area which is greater than 1 or is equal to 2 meters depth of water. In this area, in this area, in this area, and in this area. Then we want to obtain the geometric file. Then we should convert this raster file to vector or geometric file. Then come to raster to polygon. Select our depth and okay. Let's change it. I will change the color to this. Yeah. Now intersected with root. Which roots affected or inundated by depth of 2 meters? Yes. Thank you. Depth of 2 meters. That means the water depths. Yeah. Then come to intersect. Which road is affected? intersect analysis, select the master greater than 1, sorry, roots and roots, all the fields. Then can which root be affected, then change the color to which, to purple. And this you can see. This is the root is affected in 2 meters water depth. We can open the attributables and we can see all the lengths of each roots in meter. Like when we select and zoom this root, if we can go to all these tips, sent to all the return periods for generation of risk curve and inundation or damage curve. How to use this? At the first, I want to generate my analysis map. What's the analysis map? Risk analysis. Come to layout. Select my own paper size, like for A3 landscape. No, yes. Finish. Remove them. ArcGIS is also not good because it's give me some warning and errors, because this is an error. It's not automatically. It should be manually. I want to adjust this and then select to I want to only cover the spots for better view. Then untick more which all these layers. Only show the flood intensity, because the analysis maps related to the flood intensity, because our procedure is based on flood intensity or flood depth. For flood intensity, then we insert the legends. Which legends we need? Flood intensity and roads, depths, velocity and health schedules. Next, you can see this is the flood analysis map. If I change this to 2 posts, I want to delete this. Insert legend and 2 columns. I want to preview. It's maybe good. Next, give them more gaps 5. And this. I want to that means this is the low risk regions area, this color. This is the medium, and this the red is the high. If I want to also classify the velocity and flood inundation. Velocity to symbology can to classify, yes. This also to 5 class and format them. Color. This is the velocity, and then want to show the flood inundation, can classify the flood depth for 100 years period. Come to symbology, classify them, yes, in 5 class also. No, sorry, it's unique. Classify and 5 also this and this color, format them 2. This I want to change the names, the val I want to go here and come to English. And this is the inundation, and I want to change the value. Symbology. And then into the flood intensity, flood velocity, change the name. This is the velocity and this is the flood intensity, but our projects based on 2 parameters: flood intensity for use of flood risk analysis by different regions or zones, flood zones, damage zone, low, medium, high. It's related to their colors. Red is the high flood risk regions or area, and the yellow is medium, and the green is low. Yeah. We can, if we calculated this, there is a criteria. It's used in Arabic Emirates. They divided in 4 classes: very low, low, medium, and high. We can also calculate them, and then from where? From double click, come to symbology, and then change this to 4 classes, and then classify them. This in formula, like very low, low, medium, high. It's the colors started from green. Green is very low. It's maybe light green. It's light green. That means it's low, and the orange color is mean that medium, and red is again high, flood zones. Inshallah, I want to learn you some things from us, and then we come to give an example from attributable to risk current development. Come to the Excel spreadsheet. This is the Excel spreadsheet. We assume that the width of each road is 10 meters. but we can use the imagery, update imagery. We can use the real of each inundated roads widths. No, dimensions also. The length is calculated by intersect process. It's very.
You mean what?
The width, the width of each routes can be measured from using of imagery. But we assume that it's 10 meters for 100 return period only. Yeah, we discuss it on 100. But for the other return periods, the process is same. For 100, how many how many number of roads inundated? Come to here from this for the area of, like, for the less than 2 meters or equal to 2 meters. Come here, this open. Sorry. Where is the greater than? No. Or it's this. This greater than 1. Greater than 1. Open the attributes. How many? From objectivity we know about the number of routes. 411 routes affected. 411. Then come to here and Zarpa. 411 routes. Automatically it's changing. Then come to total length of routes. Total length of routes, how measure? From this. We select them all and like this. We at the first we should export this. For export over to sheet file, export routes, it's same text, save. Okay, no, then go to shapefile. Where is the shapefile? Then come to this, open the Excel. Sorry, Excel file, open, browse, desktop. Probably you can put shapefiles, text inundated by 2 meters depth of flood. Open them. Next, comma separated. Next, finish. This all the result. You can use very for easy calculation. Then select them for total length calculation in meter. How much? This one. Then select them and insert an hour. Yes, and this one. Control Z. Sorry, paste only the numbers. It's automatic change it. But because it's dependent, all the other return periods should be updated. Then the curve will be smooth. Because then the width and the maximum and its maximum damage parameters of USD dollars, $12 per square meter, and its consequence, how much its consequence, that it's calculated. This is named flood risk curve. This is the assessment process. This Excel spreadsheet is the assessment process of flood. The risk analysis is the GIS and HEC RAS, and related to the flood inundation or flood depth and flood velocity. And also this should be updated for all the return period like this. This is the method. And for the damage, the damage factor, we know about the 2 meters inundation, 0.85, the damage factor. That means 85% of the structure is damaged by 2 meters depth of flood. Or if we have survey according to this processes of our project, then if we give this information to survey team, they can calculate and collect some data from the site, and then we can calculate them in percent. And also for the we can use the imagery. From imagery also we can do this. The area and the area of roads affected from imagery, we can very easily we can calculate it. But it's necessary to the visual survey should be done and the engineering survey. Now this is finished. We know about what's the vulnerability or damage curve. The roads, which are 411 number of roads in 2 meter water depth or inundation, it's affected 85%. Inshallah, if you have any questions, you are welcome. This is the I have give some notes. The return period of one is it is equal to normal flow, no flood, and also the damage function has value include between 0 and 1. What is the 0 is no damage and 1 is high damage, and we can calculate the vulnerability or damage curve and percentage of damage as well based on observed data from visual survey. Inshallah, finish. ومن الله التوفيق. This is the process. And also for this I will save them. File, save, and also we can copy or generate them. How? And also we insert the name, a title. Flood risk analysis map. Sorry. Okay. Then come here, change its text size. We change to default and bold. And change the background. Because the map production is very important. If you cannot do this, you will be failing. At the end of the project, you will be failing. At once, come to background and change the color to this. No color. Okay. This is the title. Flood risk map, and then come to this is the legend for each items, and insert the north arrow. Yeah, it's very important. Like we have used this and this here, This is the north. I want to change the color to which? To red. It is maybe visible, or no, yellow is visible. Good. Yellow. Good. And then insert the scale bar metric, and also we can change this also to metric units, but I want to use the metric ones. Where this, and this is the scale bar. I want to give the background frame, oh format, sorry, from frame, because all the data is very huge, it's very heavy. It's affected our machine and our software, and not work properly and good. For this reason, I have purchased a very good machine from Dubai. It's very good. Its RAM is 32 gigabytes, and because in that machine I haven't installed my software, because I'm not bring to my training. This is change it. You can see I want to export or print. There is in this two options, but the resolution is depend on the export. I want to at the first I want to export this map. And also this is very important. Some, because our value is based on its name, low risk, very low risk, medium, and high. I want to give the names for each flood risk zones. Sorry, from here I want to change this to very low, very low, then to low, then to medium, this like this, medium, MIDIUM, thank you, and high risk. Now this is good. This is divided the zone and our project criteria. It's good. I want to export them. This is my nature. I want to share my all knowledge with my colleagues, my partners, and my brothers. Therefore, when I share them this training with you, then I am working advanced, deeply in other factors. Inshallah, keep contact with us for the next training. Inshallah, for the like this, for advanced trainings and flood and water supply, and also for the pavement and materials, because I am working pavement and material designer. Then I want to export this. I want to, at the first, I want to change the format to JPG or image. Then select the DPI, its resolution to high. Save and export. Velocity unit is meter per second, but if you want to visible there, we can insert very easy, like this names. And the value of the units of inundation is in meter. If you want to visible there, you can insert like the like similar to the flood intensity. We have changed the numeric model, the numerics to text. It's now generating. Let's take time. Easy patent. Come on, it's going to export. We now open this. How is the properties? It's 41 MB. If we open this, if we zoom in, it's very good. This is the resolution. Good, not good. And this is the legends. This is the flat zones. We can easily see them. And I want to print them. How to print? At the first we should prepare the page and print setup. This is selected already. Then come to this landscape P3, come to properties of our printer page, and this there is we should change to P3. This now okay, and then come to print. Desktop. This is also an error. Double window is appear, but it's now running.
You have to choose the cell because it's printing a video format.
No, I have already saved it, but I want again. And now it will be completed. No, I know my my softwares have some problems, I'm sure. Now I want to print again. Okay. Desktop saved. No, the first one is enough. When it's complete, will be appear there.
The second page you are
No, this is the error. Yeah, this is the error. It's now printing. It's take time because it's very heavy files.
But in the description it shows two pages.
Yeah, this is an error because when the first I have saved, then this screen is appear again. Yeah, when it's completed, it will be closed automatically. That now it's printing. It's busy. Yeah, it's busy now, but the problem is related to our software because it's cracked and its ability is not good, and there is no way to purchase the license. Let's take time. This is the process, but I want to close them. It's not able to print. No need. But it's this is the procedure, and also I want to change these names. This is the latest modification because it's very necessary. This is the rules. because we should know about its name, and also the name change to properties. Change this to read, and then to change to this already changed. This one, this zigzag, finish, and this one remove here. And also you can insert your name like prepared by who, and also insert some informations like some description, or I want to like this is very, it's not visible good, I want it's visible very good. This is the way for insert data frame, other new data frame. Yeah, this one. This is the flying system. This name it flying system. And come here and want to into this, and then put all the data here. Copy. No, this is not necessary. This. Now I don't. This is good. Now it should be. This is the greater. This annulation. This velocity annulation. Good. It's enough. Also I should copy, and here paste the layers and zoom in. Then come here and active them. Let's active this layer. Then come here and want to zoom this area to better way for this area. Zoom in like this area, and then come to here. I want to zoom in for better view, and then give the, I want to move this part here, I want to be smaller here, and come to give the description. Have to use the circle, and then use and this for this area, and then can fill it, no fill. This is black, and give the vector. Come here, draw line from here to here. Like a vector. Then if you want to change that, change its properties to visible, properties, line width to 3. You can see this is the description, and also I want to change this is prime. It's rounding, thickness, to visible. This is the flying system. That means it's zoom in. The zoom in the windows here, and we then can export them again. Export desktop, new project, final, save. Also, can you input the table as well? Then for like the how many in like in 2 meters and 100 roads which affected in 2 meters and inundation of water. You can put the table because it's intersected already. The quantity, how many roads is affected, and there is total length. You can use in this map also for more details. Mr. Bashir, maybe it's for the first time you see like this training.
This training,
Yeah.
okay. I mean this starting page.
Yeah.
It is.
This one. This is the final. If we zoom in, it will be better. Very high resolution. This is the LiDAR data we have used. And the mining roughness and the all necessary works we have defined it at the first using the HEC RAS model. This is the risk zones. Finish, and I will show in the other software this procedures if you want, but it's purchased. It's very expensive software. I have purchased it from US, United States of America. It's because it's good. It's viewed in 3D. We do this task in ArcGIS as well, but it's time consuming because we need for more time. But this is very automatically. When I want to open this model, ignore. This is I want to import my elevation terrain model. Okay. I want to zoom in some parts in 3D. Time. Oh, sorry, because it's in meters and it's different with it's because in meter and up to 5 meter it's deep, and our terrain models elevation is up to 1.8 thousand meters there because it's come down, but we use the water surface profile. You can see. This is all the buildings. This is the area affected by flood. If we have internet connection, I will see this is real on imagery. Do you have, Mr.? Do you have internet?
Yes, I have.
You have it, please forward. It's finished, yes. Only it's. The water is also extended in the low elevation, like it's the roads. You can see this very good.
What's the difference between 1D and 2D?
No, this is the 3D view or 3D perspective, not 3D analysis. But 2D and 1D analysis is different. It's all as well for hydrological and for hydraulic.
What is the difference?
Difference that 2D analysis accuracy is very high than 1D because it's
It has two dimensional.
no, it's regarding to the terrain model, it detected all the sensitive locations. But in 1D, it's ignored sometimes.
Because we can do.
Yeah, I have already do it in 2D model also. Do you have? It's Galaxy Note 10.
10 Plus, yeah.
No, thank you. What's the
SAIF.
SAIF N or F? F.
At the rate 1
This?
to 3. Yes. The sign was.
Oh, at the rate. Yeah, at the rate. Yeah, sorry. The rate of 1, 2, 3.
Yes.
Yeah. I want to add the base layer from easily. Okay. Thank you. I want to off the cross sections. Average cross section. Now it's open or downloading. It's downloading.
If this data is real, in 100 years, this area may be damaged. This,
According to this data,
according to this calculation and this.
No. That yes. If the flag is accurate and this much, this area is affected.
The government should take some.
Yeah, at the last year, 2019, the water is rising to yes, very. This one we can see.
This flood coverage is as per the 2 meter height or as per the maximum flow?
No. This is as per this water extent is or prone areas as per water return period.
100.
100 return period. If you want to know about the each for each depth, we should calculate like for the NGS inundations from 0 to up to 7, up to 6, up to 9 or 10 meters. But it's automatically calculated as per regarding to the terrain models.
Another question.
Yeah, this is. You can see it's good.
Yeah.
The HEC RAS file in first the video of this HEC RAS we can find from YouTube here.
From for which?
The HEC RAS file first you import to HEC RAS.
Yeah.
The video is.
Yes. Yeah, the video preparation for model.
Yes.
Yeah, I have uploaded to my channel, YouTube channel. You can download it.